expanded notation for multiplication still focuses on partial products, but it arranges them in a more abstract way. So we started with base 10 blocks, we moved to area models, and now we're moving to a more symbolic or numeric approach. So this transition will help set students up for the traditional algorithm that they'll learn in 5th grade. So to start, let's relate the expanded notation to the area model drawing. So if I want to model the problem 28 times 9 in my area model, I would draw my rectangle and divide it into sections. Have the 28 here and the 9 on the side, and then I'd multiply my partial products. So 20 times 9 is 180, and 8 times 9 is 72, and then I would add my partial product somewhere to find that my answer is 252. In the expanded notation method, I'm going to write my problem vertically. So I start with 28 times 9. And then I'm going to expand my numbers just like I did in the area model. So in the area model where I wrote it here, I'm going to write that expanded notation beside the number. So 20 plus 8. And then 9 is already in its expanded form, so I leave it there. And then in my area model, I multiplied each part of the 2-digit number by the single digit. And here I'm going to do the same thing, but I'm going to write it differently. So I'm going to multiply the 9 times the 20, and I'm going to write that here. And then I show my partial product of 180. And then I'm also then going to multiply the 9 times the 8, and I'm going to write it right below that. And then I add my partial products again and have 252. So they should be able to tie, students should be able to tie each piece of the expanded notation model back to the area model so that they can really see the connections and the progression in their learning. I'm also going to show larger problems, and as long as students keep track of the partial products, then this method also will help them to multiply each partial product. So let's multiply 4 times 3,697, and again, I'm going to write the problem vertically. And then I have to expand my number. So I've got 3,000 plus 600 plus 90 plus 7, and then 4 is already expanded. And I'm going to multiply the partial products. And here it's helpful if students can keep track, so they may want to draw lines to show what they're multiplying. So I've got 3,000 times 4. And that gives me 12,000. And then I'm going to do 600 times 4, which is 2,400. I'm going to do 90 times 4, which is 360. And then I do 7 times 4. So I've got my last partial product, which is 28. So then I add all my partial products, and my answer is 14,788. Then a 2-digit by 2-digit example, just because the keeping track is a little bit trickier for students. So again, if I did 12 times 25, and I'm going to write it vertically, doesn't matter which number I write where, because it's commutative. And then I need to expand each of my numbers into their place value components. So here I'm going to multiply 20 times 10, which is 200. And I'm going to multiply 20 times 2, which is 40. I've got to multiply the 5 times the 10, which is 50, and I've got to multiply the 5 times the 2. So each part gets multiplied by each of the other pieces. Just keeping track of that will be important for students. And the answer there is 300 when you add your partial products.